Okay. Yeah. So tell me, Ikshita, what was your uh, what do you call? What was your the reason for the question that you asked on scientific notation? I'm certainly curious to understand what are those areas of doubt or things that is still in your mind that you want to clarify. Or think about it, come back to me, okay? Vivan, you were saying something.
So maybe you could learn about like the geometry and more specifically on like area of like trapezoids.
Okay. Area of trapezoid. Wonderful. Hey Ashrit. Ashrit, can you hear me okay? Okay. And area of trapezoid. Okay. Bivwan, any other topic that you have in mind? No? Okay.
Area of a rhombus.
Area of a rhombus. Area of rhombus, area of trapezoid. So we want to focus on geometry, okay?
Can we do like rational and irrational numbers and like the differences in numbers?
Okay, so now, number system, I'll probably park it because that will be our first topic once we start from February the beginning. Okay, so we can probably park that one, and eventually we'll start with that only. So we're just a week away from that. Okay, so you guys want to learn about the area of rhombus and area of trapezoid.
Circle.
Area of circle is okay. Area of circle also. So area of circle, area of trapezoid, and area of rhombus. These are the three things that you want to know. Unfortunately, you are trapped with a very bad teacher who doesn't just give the formula.
You tell a story first.
I don't even tell a story. I always try to make sure that I don't give you a formula. Say, okay, here's the formula. Use this like a magic wand and use it. No, I don't do that. I don't believe in that. Yes, Dikshita.
Instead of learning the scientific notation, can we learn statistics and probability?
Yes, that could be another topic that we'll try to cover. We might not be able to cover everything today, but we'll at least do a jump start. Okay, make sure that all the edibles are finished before you come to the class. Let the teacher do the teaching. Okay, so let's start with area of circle, area and perimeter of circle. Then we'll go to rhombus, then we'll go to trapezoid. Yep. And when I explain these things, area of circle, I will not explain you how the formula is derived because that will be a little too much for you guys. Okay?
I know.
I'm sorry?
I know.
You know what is the formula. How is that derived is what I don't want to teach right now because that will be a little too much for you guys at this point.
Okay.
So, now, circle. Let's start with circle. The whole world is like a circle. Yeah? So, it's very important to know about the circle. This is more like an egg. Yeah, this is a circle. Vasundhara, any question that you have that you would want to focus on? I'm just trying to make sure that I cover the entire class. I could not hear you, Sundara. Lakshita, Sanvita, anybody? Any particular topic that you would want me to cover apart from what we discussed? About okay. So first thing is area of circle. Now going back down the lanes of history, when you talk about area of anything means the space that it takes on the surface. If you're talking about any shape, be it a triangle, be it a rectangle, rhombus, kite, trapezoid, pentagon, hexagon, octagon, nanogon, whatever it is, everybody gone. Whatever gon you're talking about, area of that means the space that it takes on the surface. and perimeter means the length of the boundary. Okay. So in case of a circle, this is the only exception I have for you guys, where I'm saying that I will tell you the area formula for area of circle and formula for the perimeter of a circle, and just memorize it for now. Once you guys grow a little older by a few years, I will explain you again how these formulas were derived, because this needs a little bit of understanding of calculus, which is way too early for you guys. So that's why I'm parking that one. But in summary, if I say area of a circle, area is nothing but pi r square. So any circle that you look at, the only and the most important identity that circle has is the radius. As soon as you say that the radius of the circle is 5 centimeter, you don't need any other information to define the circle. Okay? So, and that radius is r. And pi is a constant given by mathematicians in the ancient times, whose value is 22 by 7. It's like another constant, like the numbers 1, 2, 3, 4 that we know. Pi is nothing but another constant whose value is 22 by 7. Yeah.
Have you also used the decimal part of that pi?
Now you have a number, you can play with it. You can write this as 22 by 7, you can write this as 3.1416, and then the recurring power on that, up to you. As long as you know how to convert a fraction to a decimal, it is up to you. I am not a big fan of memorizing things. I have just memorized one, and that's my favor to the math world. Saying that, okay, you forced me to memorize this formula, I memorized it. But I'm not going to go beyond this and try to memorize this as 3.1416 or whatever it is. Because I know how to do division, how to convert fraction to decimal. I can do that. Yeah? So, I will leave it to you guys, okay? Pi means 22 by 7, or when you convert this to decimal, you will get 3.1416. People memorize this as 3.14 also. I will leave it to you guys. Now, as long as you know, remember the value of pi, it's not only with respect to circle. Pi becomes a new number in your number book that you can use anywhere. Anywhere you come across pi, you can think of pi as 22 by 7. As simple as that. Yeah? Like you know 3 is 3, 2 is 2, pi is 22 by 7. That way. Okay? Now, so if you know the radius of a circle, you can find out the area, which is nothing but pi r square. So if I ever say this is 5 centimeter, you will put the value here and the area will become 22 by 7, which is pi times r square, which is 5 centimeter square. So this becomes 22 by 7 into 5 into 5, 25 centimeter square. Do the calculation and you will get that. Now the second thing I will force you guys to memorize at this point is the perimeter of a circle. Perimeter of any shape is nothing but the length of the boundary. So if I start my journey from here and walk along the boundary of the circle, the total length from here to here, that will be my perimeter. If I am talking about a triangle, my perimeter would be, I walk along the boundary from here, go from here to here, travel all the way to the top and come all the way down to the same point from where I started. The total length from here to here to here is my perimeter. So in case of a circle, the length of the perimeter is nothing but 2 pi r. And you know what? How did I convince myself to memorize this formula? It is this way. Pi r to the square is the area, and if I bring 2 down here, that is my perimeter. Yep.
Can we also call it circumference?
What is that?
Is it perimeter of a circle circumference?
Yeah. It depends on how strong your English is. So it's called perimeter, it's called circumference. You can call it border, you can call it boundary, and there will be a few more words for sure. Yep. So, but yeah, perimeter or circumference, both are same. Now, so see, I'm just giving you guys a very dirty clue how you can memorize this. Pi r square. So see, pi r remains same in area and perimeter both. Where it's an area, it becomes a power to the r. Where it's a perimeter, becomes a multiplier or coefficient to this one. If that helps you memorize, wonderful. If not, if you have better or different way of memorizing it, I'll leave it to you guys. Any questions so far? Ashrit, Bibhuvan, Dikshita, Vasundhara, no questions? Sanvita? Okay. No questions. So, this was my easy picking because I knew that I'm not going to tell you guys how to find out the formula for area and perimeter. That's why I picked up this one first. Now we'll go to trapezoid and we'll go to rhombus and find out the area of those and the perimeter of those. So, are you guys with me? You both are with me anyways, physically. I'm asking the kids on the screen also. Everybody with me? Okay, cool. And let's see who joined in between. I see one more child. So Sanvi joined, I saw her. Pranav, okay, Pranav was not there, Pranav joined. Good. So Pranav and Sanvi, whoever joined a little late, just telling you guys that today we picked up 3 things that the kids wanted me to teach. One is how to deal with the area and perimeter of circle, how to find out the area and perimeter of a rhombus and trapezoid. Okay? So that is what we are going to do today. First I will tell how the formula is derived and then I will tell you guys how, once you know how the formula is derived and you understand all the properties, then you can literally play with it, right? So any questions? Ashrit, are you with me? No, I'll just randomly keep on calling out names just to make sure that everybody in the class is with me. That's why I'm asking Ashrit's name. Yeah? Okay. So, alright. So, let's look at the next shape called rhombus. This is a rhombus. This looks somewhat like rhombus. Now, look at another shape by the side, which is nothing but the square. And as I would have told you guys in the past, rhombus is not a shape that existed by itself. It is something that was created by squeezing a square. And again, I don't have any proof or evidence of that. Okay, this is my way of relating things. So when you have a square and you squeeze it from 2 corners, what happens is your square becomes thinner and taller. That's exactly what happened. When we took this square and squeezed it, it became a rhombus. What is important here to know is, in case of a rhombus also, all of your sides are of same length as a square. Only difference being, in case of a square you had all angles 90 degree. Unfortunately that is not the case anymore because you squeezed it, right? If you squeeze me, what will happen? I'll become thinner, right? I wish somebody does so, that I lose some weight and become thinner. But those apart, coming here, when I squeezed it, this angle became smaller than 90 and this became bigger than 90. Okay? So you will sometimes when the drawing skills are as great as mine, you will see that square and rhombus will look similar. But keep in mind, your square and rhombus are different. Squares are much wider, much more vertically oriented compared to this one where it's thinner and the angles are not 90 degree. Okay, but yeah, all 4 sides are the same. That is one information. Now, other thing, if you guys recall, if you have a rhombus, the opposite corners when you join them, these are called diagonals. And does anybody remember what happens with the diagonals?
they become 4 right angles. My bad, 4 right triangles.
Don't go that far. Tell me about the relationship between the diagonals.
They're all equal.
Something else.
Depending on the angle.
You tell your answer. He will tell his answer.
They all have a hypotenuse.
Hypotenuse? No. Okay. Anybody on the screen? I'm just trying to see how much you guys recall. If I have a rhombus, when I join the opposite corners, these are called diagonals. These two are diagonals. Let's see if I say this is A, B, C and D, and they meet at this point called O, AC and BD are called diagonals. Okay? Now, I want to see if anybody in the class remembers what happens with the diagonals. What is the relationship between these diagonals? Yes, Sandri. In case of a rhombus. You trying to say something, Sandri? Anybody else? Deekshita, Myra, Pranav, Vivan, Vasundhara, anybody?
I was going to say they're perpendicular.
They are perpendicular. So, in case of a rhombus, the diagonals are perpendicular bisector of each other. Meaning, when they meet, they bisect each other. Meaning, this diagonal is bisecting this, like BD is breaking AC into two equal parts at this point. Similarly, AC is breaking BD into two equal parts at this point. And as Sami said, they are perpendicular also, meaning all these angles are 90 degrees. Yeah? So, when you are talking about rhombus, maybe I think you can move a little bit to this side so that you don't have to stretch. So, when you are talking about a rhombus, first thing that you would know is all the four sides are same because this is a squeezed version of a square. This is a thinner, taller version of the square. All the four sides are same. And the diagonals, when you join the opposite corners, they are perpendicular bisector of each other. Perpendicular bisector. Remember this word. Perpendicular meaning they are perpendicular, making 90 degrees with each other. And bisector meaning they bisect. They equally split into two parts. Myra, your thumbs down before should be a thumbs up now. Yeah? Okay. So, as long as you remember that property, that is good enough. So, now look at this. You got this rhombus is split into four triangles now. And you will see this side and this side are same, meaning AO and OC are same. DO and OB are same.
What about DCBA?
What is that?
DCBA.
DC and BA. They are anyways the four sides of the rhombus, right? They are same. Right? So, BO and OB are same.
Yeah, but DCBA is also parallel lines.
I'm not going there. I don't need that information. Even if that information exists, I don't need that right now. Okay? Now, look at this. We have four triangles here, and I'm saying that all these four triangles have same area.
So it'll be each one.
No, I'm saying, don't conclude just because I'm saying so. You have to think about it also. I'm saying that these diagonals split this whole rhombus into four triangles, right? And I'm saying these four triangles are same size, they are congruent. Who remembers what is congruence? Okay? Anybody on the screen? Yadikshita, what is congruence? Dikshita,
Like a shape that is like same.
exactly the same. In mathematical terms, if you are saying two shapes are congruent, meaning they are exactly the same, their area is same, their sides are matching, their angles are matching, correct? Now, you said that, I said that all these four triangles are congruent. But how? So let's take one example, okay? Triangle AOD and triangle DOC. So this one in blue and this triangle in black. I'm saying, let's take these two examples, these two triangles, and I'm saying these two are congruent. Why do you think so?
Because if the lines are perpendicular, it means the shape should also be like that.
Cut it there. Congruence is based on certain theorems. And I'm not sure who all remembers that. There are four theorems of congruence. They are called SSS, SAS, ASA, and RHS.
For right angle.
So here, these three are for every triangle. This one is for right angle triangle. For right angle triangle, if the hypotenuse and one of the side match, they are congruent. Did I teach the theorem of congruence in the class before? I think I did. Yeah. So anyways, when you say congruence meaning if I say this triangle are congruent, meaning they will have same area, they will have matching properties. Okay. So here I am saying between this triangle and this triangle, I am saying they are congruent, and we will use this theorem RHS. If you guys have forgotten about other three theorems, it's okay. We'll come back to that. But there is one theorem that you need to remember is RHS. R stands for right angle triangle, S stands for hypotenuse, and S stands for side. Meaning, if there are two right angle triangles and hypotenuse matches and one of the side matches, then both the triangles will be congruent. Now, look at this triangle, this triangle. What is the hypotenuse here? This one? For AOD. For AOD, the hypotenuse is what? AD. And for this guy, DOC, the hypotenuse is what? CD. And AD and CD both are same, because for rhombus, all four sides are same. Correct? Are you guys with me or not?
Mm-hmm.
Everybody? Okay. Now, so hypotenuse are matching, and this side is anyways common. So AO is common in both the triangles. I can safely say these two are congruent, meaning these two areas are matching. Okay. Now same thing, you look at this triangle and this triangle also, same thing. Hypotenuse is matching and this side is common. So this triangle and this triangle is also congruent. If you look at this triangle and this triangle, same thing. Hypotenuse matching, this side is common. So this rhombus is made of four equal or four congruent right angle triangles. Am I talking to myself or am I able to reach you guys? Everyone, is it clear better?
Yes.
Okay. So basically, if you look at a rhombus, it is made of four congruent right angle triangles. So if I find out the area of one triangle, one right angle triangle, and multiply that by 4, that will give me the area of the rhombus. Do you guys agree or you don't want to agree? Shamli, try to disagree once, please. Agree? Okay. So coming back to a serious point. So I'm saying, based on what we saw here, a rhombus is made of, is a quadrilateral where all the four sides are same, and when you join the opposite, the diagonals, they perpendicularly bisect each other, meaning all the angles are 90 degrees and these sides are equal. Now, so after joining the opposite corners, we saw this is converted into 4 triangles, and every triangle is congruent. So this is congruent with this guy, this is congruent with this guy, this guy is congruent with this guy, this guy is congruent with this guy. That means this rhombus is made of 4 right angle triangles. 4 into, let's pick up one triangle, AOD. Okay, this one, the one in black. If I find out the area of this triangle, multiply that by 4, that will give me the area of a rhombus. Yeah? Now, what is the area of this triangle? This is a right angle triangle. 4 times area of this triangle. Area of a right angle triangle is what? Half into base into height. What is the base? Base is AO. And what is the height? OD. Yeah? No?
Can we go to the bathroom?
I'm saying area of the rhombus will be equal to 4 times area of one of the triangles. So what is the area of one triangle? Half into base into height. This is my base and this is my height. Now the second information we have is this is half of this one and this is half of the whole thing, because my diagonals are perpendicularly bisecting each other. Correct? So I can say this AO is nothing but it is 4 into half, so it becomes 2. So let's say this is from here, I'm going here. Okay, this equals 2 times AO. AO is what? AO is half of this diagonal. So I'll say diagonal 1 divided by 2. And OD is the half of the second diagonal. So let's say second diagonal, I'll say D2. This is by 2. So this becomes 2 into D1 into D2 by 2 into 2. That means D1 into D2 by 2. So my area of a rhombus becomes diagonal 1 times diagonal 2 divided by 2. Now again a quick recap of what we did. We have a rhombus. Rhombus has 2 properties to remember. One is all the 4 sides are equal because it's a squeezed square. And then in case of a rhombus, the diagonals perpendicularly bisect each other, meaning they meet at 90 degrees and they divide each other into half at this point. So from that we saw that this rhombus is split into 4 right angle triangles. And when we looked at these right angle triangles individually, by the theorem of congruence RHS, we see that this triangle and this triangle is congruent, this triangle and this triangle are congruent, this triangle and this triangle are congruent, this triangle and this triangle are also congruent, meaning rhombus is made of 4 equal congruent triangles. Meaning if I find out the area of one triangle and multiply that by 4, that gives me the area of the rhombus. So 4 times area of one triangle. So 4 times half times base times height. Base times height. And this base is half of this triangle and this height is half of this triangle. So I am saying 4 into half of this diagonal, diagonal 1 and half of diagonal 2. So that is how we got area as 4 into half of diagonal, half times diagonal 1 by 2 times diagonal 2 by 2. And this gave me D1 into D2 by 2. So this became a formula for us. How to find out the area of a rhombus? Area of a rhombus is half into D1 by D2, where D1 is one diagonal and D2 is the second diagonal. And as I said, diagonal is nothing but the length of this one which joins 2 opposite corners. Is everybody with me? Ashrit, Vivan, Dikshita, Myra, Vivuan, Sanvi, everybody with me? Vasundhara? Ashrit, were you able to follow me?
Yes.
Yeah, okay. Yeah, so see again, when I keep on calling out names, It is not to put anybody on the spot. I'm just trying to make sure that I'm not teaching myself. Okay? Now, so you guys saw and you guys would remember that area of a rhombus is nothing but half into D1 into D2, where D1 is one diagonal, D2 is the second diagonal. And again, you would have seen how did we arrive at this one. So tomorrow, if you get a question, let's say, okay, fine, find out the area of a rhombus where, see, nobody will give you very straightforward question, okay, to solve. You have to just apply a little bit of your understanding of the properties of shapes, and then you should be able to solve it. Let's say you get a rhombus and the question says find out the area of this rhombus where one diagonal is 18 centimeter and one of the side, length of the side is 8 centimeter.
We're going to ponder this theorem for this.
Yeah, so don't rush. Think. If you are given this information, see, you know the formula that area of a rhombus is D1 into D2 by 2. So this is when you are applying your technique, right? The tan method. Now here you are given D1. One of the diagonal is given to you, but they have given you a side, not the value of the second diagonal. If you have the second diagonal given to you, you would have just multiplied and divided by 2. You were done. But the teacher is as bad as me. He's trying to trick you. Right? Okay, we want hairstyle later. Okay, here coming back to this one. So coming back to this one. Now, just draw it. So you got one diagonal, let's say this is 18. Okay? So we know that both the diagonals meet and bisect each other. So if this is 18, that means this part is 9 and this part is 9. Okay, that one you know now. Side is given as 8 centimeter, meaning this side is 8. Okay. Now, see, this question is wrong. This question is wrong. I did not choose the right number. Okay. You cannot have a hypotenuse smaller than any other side. So let's say this is not 18, maybe this is 14. That is when it will be technically correct. So now you have this side is known to you, this side is known to you. What you mean is this length. And how you can find out? If you find this length, then you multiply by 2. You got second diagonal, put it here, you're done. Yep.
I thought the diagonal was 14, not 8.
Diagonal is 14 only.
Then
This
how-
8 is the side.
when you put it on the diagonal,
This is not the diagonal. This is the side. 8, 8, 8, 8. The diagonal is this one and this one.
okay.
Yeah. So did you guys get what I was trying to do?
Yeah.
Kids on the screen. Vasundhara, Lakshita, did you guys get it? Okay. So what I'm trying to say is, we need to be very clear about the property of the shape that we're talking about. That is one thing. And then once you have the information, put it here. See, what did I do? Did I struggle or break my head to find out D2 straight away? No. I said, okay, let's see what all information I have. I have a rhombus. I have diagonal 1. So let's draw it. There are two diagonals. This is 1, this is 2. So one of the diagonals is known to me, which is 14. And I know by the property that the diagonals bisect each other. So if this is my 14, this is 7. This part here to here is 7. So we got that information. Now one of the sides given is 8. So I mean all the sides are same, right? So this is 8 centimeter, this is 8 centimeter, this is 8 centimeter, 8 centimeter. When you put the things on the piece of paper, you will see that things start becoming much more clear actually. Who's yapping right now? Stop yapping. Who is this gentleman? Okay. Anonymous. Okay. Alright.
Do they just randomly join?
I don't know, somebody joined and making statements. If people make statements based on their intelligence level, right?
What stage?
If somebody is not able to understand maths, they will say this is yapping.
Wait,
And I take it.
wait,
I-
Mr. Kumar, which stage?
I don't care. That's okay. Somebody is making statements, that's okay. Now, coming back to this one. So we have information. You just plot it and then you try relating that with the property of the okay. Adam, can you stay properly?
I was just having my drawing break.
He's
That is out of syllabus.
He's talking about the pushback thingy.
That is out of syllabus. I'm not here to entertain anything which is not in syllabus. Okay, so let's keep it aside. So coming back to this one, once you have the information, plot it and then relate it, and then that should be good enough for you to proceed. So while you would know the formula, not every question will come to you for just applying the formula blindly. So always look at the information, draw it, and then try relating it. That should give you a clue with respect to how you want to proceed. So is this part clear to everybody? Vibhuvan, Myra, Ashrit, Dikshita, yeah? Okay. Now, so this was with the area of rhombus. Now comes area of trapezoid. Now tell me, okay, before I leave rhombus here as art fund, if I have a rhombus, how do you find out the perimeter of that? Yeah?
You just have to calculate the size because when you said that you can extend it to a
It's
square.
a too long an answer. It has to be a two-word answer.
The 4 times the hypotenuse.
4 times the side.
That's not
Because
The
it's like a square.
hypotenuse. See, when you're looking at numbers, these are called sides. These are 4 sides, and they're all same. You'll say 4 times the side. That's it.
okay.
Yeah. So
I don't think we
anybody on the screen, I just explained how to find out the perimeter of the rhombus, and that's a no-brainer because all the 4 sides are same. It'll be 4 times the side. Yeah. Do you guys agree or you don't? What is that? We'll not do a discussion which has no meaning to it.
But what if the rhombus is like out of shape? Will we still count all the sides?
That's what I
Rhombus will not have any other shape. Rhombus has only one shape where all 4 sides are same.
I think he's thinking about it.
It could be small, it could be big, but your rhombus is always formed by deforming a square, meaning squeezing a square. And in case of square, all the 4 sides are same. In case of rhombus, also your 4 sides will be same, no matter what. Okay? Is everybody with me? Okay. Now, so with rhombus we learned how to find out the area, which is d1 into d2 by 2, and how is that arrived, that also we saw. Now that we saw what is the perimeter of a rhombus. Next comes a trapezoid. Who will tell me, except Arun, what is a trapezoid? How do you define trapezoid? Except Arvik also. No, let everybody speak, right? I mean, I give chance to everybody. Who will tell me what is a trapezoid and what is the key property of a trapezoid? Because if you know the property, you can do wonders.
A trapezoid only has 2 parallel sides.
You can say trapezoid only has 1 pair of parallel lines. That's it. There is nothing else known about it. Yeah. Yes, yes, Asit.
It's like three triangles. If you like split it.
I'll come to that. But to begin with, right, my simplest definition or understanding of trapezoid would be a trapezoid is a quadrilateral, meaning it's a shape which has four sides, which has only one pair of parallel lines. Only one pair. Because if I say a trapezoid has two parallel lines, that will not remain a trapezoid, that will become a parallelogram or a rectangle. So I'm saying before a trapezoid dares to become a parallelogram or rectangle, I will restrict that guy, saying, boss, you don't have more than one parallel line. So you have only one parallel line. That is how you don't lose your identity of being called a trapezoid. Okay? Yeah? So we know that, okay, there is a trapezoid. I mean, a trapezoid is a trapezoid because it has only one pair of parallel lines. So this line and this line are parallel. I never said that they are equal or anything else. Just one pair of parallel lines. Or whenever you say a parallel lines, meaning there are two lines that are parallel to each other, meaning the distance between them remains fixed. It doesn't change. Whether you look at them here or look at them here, the distance between them remains the same. Correct? Sandri, are you with me? Okay. So now here, if you look at this trapezoid also, these are two parallel lines. The distance between them here and here and here and here and here remains the same. Yeah. With that understanding, let's move on. So now trapezoid is not giving me the comfort. How do I get a formula? It looks a very distorted shape. How do I make it simple, easy? So let's draw a perpendicular from here to here, and from here to here. Now I see things which look better. A, B, C, and D. This was my trapezoid. Okay, don't keep murmuring in the background. Pay attention. Now we have a trapezoid. What did I do? From here I got the perpendicular here, so this is 90 degree. And from here also I got the perpendicular, so this is also 90 degree. This is 90 degree, this is 90 degree. Now let's say the points where it met, I will call it E and I will call it F. So this trapezoid can safely be split into three shapes. One is a triangle, this one, ABE, this part, okay. Then there is another triangle, DCF or DFC.
What happened to D?
Coming to it, I'm coming to that.
The CE.
Which one?
My bad.
So I said there are two triangles. By dropping perpendicular, now we have two triangles that you see as colored here, ABE and DFC. And then we have a rectangle also in the middle, which is AEFD. So if I find out the area of this guy, area of this guy, and area of this guy, and add them together, that will be my area of the trapezoid. Do you guys agree or you don't want to agree?
No, because then you won't have a...
No, don't argue for the sake of arguing. Think and say. Because if you give me a wrong argument, I would not love it.
So be to the hypotenuse plus the
See,
part.
okay. No, don't waste your brain for no reason. Here, 1 plus 2 plus 3.
That's it.
Is there anything complicated about it?
No.
Why are you wasting your time then?
No, because then how are we going to find it? Do we just have to count all of them?
What do you mean count all of them?
For the perimeter?
We're not counting.
Am I talking about perimeter right now?
It's from the area.
Oh.
It's slow.
So we had 2 triangle plus 1 rectangle.
Spare the poor teacher time by excluding those unwanted talks. Right?
Yeah. Yeah.
Now, okay, come back to this one. So I'm saying, this is my trapezoid. I dropped a perpendicular from here to here, which is meeting at point P, and from this point I dropped another perpendicular which is meeting at point F. Okay. So now this has split this whole shape into three pieces. This is my right angle triangle, this is my rectangle, and this is my other right angle triangle. Everybody agrees with me so far or not? Dikshita, are you with me, Vita? Okay? Okay. Now, so if I find out this area, and this area, we'll put it. So let's do it this way. ABE, this one. Okay? Now, area of this is right angle triangle, half into base, BE, into height, AE. This is area of this guy. Then AEFD, this one. This is rectangle, so length into width. So it will be EF into width. That will be DF. Guys, stop fighting. Now, this is my area of the rectangle. Length times width.
4 pages.
Then the third one. Abhi, stay still. Then area of this right angle triangle, which will be again half into base. Base is FC.
Times height.
FC times height is DF. So between these three, AE and DF are the same thing, right? So wherever I have AE, I'll replace. Wherever I have DF, I'll put that as AE. So this DF will also be AE. So from this one, what do you see? AE is common. So I'll take AE out. Then I have half into BE. Half into BE plus AE I have taken out, so I have EF, which is this length. Okay. Plus this one here. AE I have taken out, so it is half into FC. Half BE plus half FC plus this one. Okay. Now, what I want to do is take half also out. So half AE is out, half is also out. So I have BE, this part, plus this becomes 2EF. 2EF. Because I took half out, so this did not have a half, so this became 2EF. Plus half here out, so this becomes FC. So what I have is BE plus 2 times of this value plus this value. Now this value is nothing but equal to, so look at this. I have got half into AE, half into AE, this height, multiplied by BE, this BE plus EF plus FC. BE plus 2EF plus FC. So what I will do is, I will put BE plus EF plus FC together, and one extra EF that I have, I will keep it aside. BE plus EF plus FC, BE plus EF plus FC. This is this length. So this is one of the parallel line, and then other EF is this one. EF and AD are equal. So now if you look at this part is this line, and this part, which is this one, is equal to this line. So this is sum of two parallel lines. Okay, confusing, right? Let's go through it. So simple, it's very simple. Let's go through it. I have a trapezoid. I dropped a perpendicular from here to here. So I have trapezoid, meaning it has just two parallel lines. This one AD and BC. I dropped perpendicular from here onto this side, which met at E, and from here, which met at F. Now, by drawing those perpendicular lines, what is happening is, it got split into three parts. This right angle triangle, this rectangle, and this rectangle. If I add the area of this triangle, this rectangle and this triangle, that gives me the area of the trapezoid. So area of this triangle, half into base into height, half into base into height. This is rectangle, so this will be length times width, so EF times this. And then this triangle again, half into base into height. So from this, what we found was AE and BF are the same because this is the height, the distance between the two parallel lines. So we took that out and then we got this value. Okay. So by taking this out, we found that this whole thing became BE plus 2EF plus FC. Now 2EF, we'll take one EF out. BE plus EF plus FC is this side and this EF is nothing but this one. So this became sum of two parallel lines. So this becomes half into AE into AD plus BC. Now, how do you relate this formula? You will say area of a trapezoid is half into AE, which is the height, the distance between the parallel lines multiplied by sum of the two parallel lines. Everybody is confused, stressed out?
Sleepy.
No? Okay, so whenever you get super excited for without a reason,
No, I need to just add it.
no, hear me out. Whenever you get super excited without a reason,
It becomes turquoise.
take a deep breath and calm yourself down. Okay? Now, coming back to this one. So again, we just added this area and this area. That is what you see here. We took the common things out and then we got this. And then this plus this is this length. This is one of the parallel lines. And EF is equal to this one, which is the second parallel line. So your area of trapezoid is half times the distance between the parallel lines multiplied by sum of the two parallel lines. Got it or did not get it?
Wait, don't we really get home?
Dikshita is not sounding very convincing. Now, right? Yeah? So, okay. 2 minutes if you guys pay attention here, okay? This was a trapezoid. What you know, it has one pair of parallel lines. This part is okay? And when you have parallel lines, the distance between the parallel lines remains the same? Yeah? Now, in this trapezoid, what did we do? We dropped a perpendicular from here to the opposite side, which is meeting at this point. And again, from this corner also, we dropped a perpendicular. Why? Because we wanted to split this into easier, simpler objects. Now, after doing this, we have one right angle triangle, one rectangle, another right angle triangle. Yeah? To find out the area of this trapezoid, we need to find out the area of this triangle, area of this rectangle, and area of this triangle. Yeah? Yeah? Dikshita with me?
Yes.
Now, area of this triangle, this is a right angle triangle. Half times base times height, half times base times height. That's what you see here. Area of this rectangle, length times width, length EF times width. Yeah? And then this area of this triangle is half times base times height, half times FC times height. Yeah? Is everybody with me?
Yes, sir.
Okay. Now, everything that I have here, we see that this AE and BF are the same. So everywhere I have, instead of having AE and BF as a separate thing, I replace everything with AE. So I am putting AE. Okay. And then we start taking things, common things out. So AE is here, here, and here. So we took AE out. Now we are left with half times B plus EF plus this. Okay. And again, when you do this calculation by yourself, you will be able to appreciate this better. Okay. Because I saying AE, EF, BC, KB, YZ, CP will not make any sense. When you do the scratch work by yourself, by drawing it, probably it will make more sense. But what I'm trying to say is the common things which are same, we took it out, and then 1 by 2 also we took out. After that we got to this point. Half times A is common, and then we have BE plus 2EF plus FC. BE plus 2EF plus FC. That's what we got from this one. Okay. So BE plus EF plus FC is one side, and another EF, that extra we have, that is nothing but this side, equal to this one, right? Because it's a rectangle, upper sides are equal. So from this we converted this to a formula which says area of a trapezoid is half times AE, which is the perpendicular distance between the two parallel lines, multiplied by the summation of two parallel lines. Yeah? Pranav, Lakshita, Ashrit, take a deep breath. Take time to take a deep breath. Yeah. Yeah? Again, try to take a deep breath. Alright. So, it's time to go. Time for taking deep breath again. So, okay, coming back to the point, one line summary. Area of a trapezoid is half into perpendicular distance between the parallel lines multiplied by the summation of the parallel lines. And area of trapezium, the area of rhombus is half into multiplication of diagonals. That's what we saw, how it is arrived at, and now for you guys to practice more. Yeah? Alright, so I'll let you guys go, have fun, and we'll meet again next Saturday. Wait for the assignments. Practice some problems that will clear a lot of dust. And in the formula, how it is arrived, you can watch the video and do the scratch bar by yourself, okay? Try doing it yourself also. That will also make it a little bit more interesting for you, okay? Yeah? Alright, so have fun. See you guys next Saturday. Bye Shrit, bye Nikita, bye bye.
I
Bye Shrit.